I've been getting a lot of questions about the LEDs that I wired up for my MQX quadcopter, and it's really nice to fly at night. It's really fun to fly at night, and I think that people are really going to enjoy flying it at night. So I wanted to give a short video of just everything about LEDs. LEDs are the way to do it. As you can see, there's a lot of different ways to wire these up. Here's a set that I made, and I used 2 watch batteries. And you know, there's a lot of different ways to do this, and I'm going to show you how to figure out ways to wire up your own LEDs. A lot of people do like to use these kind of light strips. Now, these LED strips have 3 LEDs on them, and so they can't run at anything less than about 12 volts. And I'll explain why a little bit later. You'll understand why 3 LEDs in series it increases the minimum voltage that you need to run at. And so these need to run on basically a 3-cell LiPo battery, and that can be inconvenient on micro aircraft. We'd like to run at a lower voltage so that we can use a smaller battery like the watch battery, or so that we can use a battery like this, which is just 4.2 volts at full charge and 3.7 volts under load, and this will save weight. And in addition, we'd also like to sometimes be able to wire directly into the power board from our micro aircraft and just use that. And a lot of folks have been doing that with the MQX, just wiring up right to the board where the battery connects and getting their power for their LEDs that way. And that leaves you with 4.2 volts. So you can't run 3 LEDs like this with this big old resistor. Now this resistor on here is a 300 ohm resistor, I believe. Yeah, 331. Is that what that says? Yeah. So that so when you run 12 volts through a 300 ohm resistor and all these LEDs, you're going to end up using a lot of energy. And these are convenient, but they're not very efficient. And if you wire up your own LEDs, you can make a system that's really efficient, which is going to make it lighter. It's going to give you a longer run time. My LED system for my MQX can run on a battery like this for over an hour and be at full brightness. So that is a lot more efficient than one of these. So, but if you want to get that extra efficiency and everything, you do have to do a little work, and that can be a little tricky because you do need to wire up your LEDs yourself. To get started wiring up your LEDs, obviously you need some LEDs, and I like to get mine from Super Bright LEDs. They have a really nice online store. You can go in and you can select all your LEDs, and then you can order them, and they're not very expensive. They range from like 20 cents for the not unpopular colors, I guess the orange ones and stuff, up to maybe $1 for the other colors like violet and the bright white ones and stuff. So I usually order those in packs of 10. You get a little discount if you order 10 or more. And if you order a lot, like 100 or more, you get a big discount. You can also get your LEDs from Radio Shack, of course. And if you have a store where they have the components and stuff, then this can be kind of convenient if you need one in a hurry. But they're a little bit more expensive than when you order them online. You're going to need some resistors. Now, I bought this giant resistor pack from Radio Shack, and it comes with resistors. They're like that. It has a lot of different ones, and you have to know the color coding to figure them out. And once you figure them out, write what they are on there, just so you know. You can also measure them with your multimeter. I think that's what I did for most of these. Let's just measure them, and I wrote what they are. Now, you also need some wire. Now, I like to use this magnet wire, and this is just Radio Shack magnet wire. And I think that green is probably the largest magnet wire that I would use. I don't know what gauge this is, it doesn't say, but green is probably the thickest one that I would use. You can get this at Radio Shack, and it comes in package of 3 with the green and the gold, which is a little thicker, and then it also has a red wire, which is a lot thinner, which is about the same gauge as the motor wires on the MQX or on the MSR or something. If you need a little bit more heavy duty installation, I like using servo wire. This wire is pretty good for wiring up LEDs, and all you do is just pull off one of the wires and use just the 2 that are left over. If you're wiring up an airplane and you need long runs of wire and you can't really, you know, tighten it down very good, and you're worried about that maybe it's going to be vibrating around in the plane or something, you can use thicker wire, but just keep in mind it's going to be heavier. And the last thing that you need is you're going to need some heat shrink tubing or some electrical tape or some insulating tape that you can use to insulate the resistors and the LED from each other so you don't get a short. I'll show that in a minute. So there's a few things that you need to know about the LEDs that you buy. One thing is the brightness. This is the brightness right here. It's usually listed in millicandles. This is 18,000 millicandle, and you need to know the viewing angle. This is 30 degrees. So that basically means this is throwing 18,000 millicandles out in a 30-degree cone out through the front of the LED. And so that spreads the light out, 30 degrees. Now you can get different viewing angles. Some of these are, 45 degrees. Some of them are real spotlight type, like 15 degrees. And some of them are 360 degrees and so on, very diffuse. So you need to pay attention to that, because that's going to determine how your LED is going to look. And then also, the other thing that you need to know is you need to know the forward voltage of the LED and the nominal forward current of the LED. And in this case, I had to look it up. They didn't put it on the package, so I had to go back to their website and look it up. But this one was 3.4 volts and 20 milliamps. So that means, at 20 milliamps, it'll be its maximum brightness there, 18,000. So ideally, that's what I want to get to run through it, 20 milliamps. And now, I also got some LEDs. These ones from Radio Shack, 5 millimeters, and it lists the information on the back of the packages for those. So there's the brightness 7,000, there's the viewing angle 30 degrees, current is 25 milliamps, and the forward supply, forward voltage 3.3 volts, 3.8 max, 3.6 max. One tricky thing when you get LEDs is determining which is the positive and negative side. Now, if you wire them up backwards, nothing will happen. It's a diode, so current only flows one way, and it only lights up if you get the current flowing in the correct direction. So it can be tricky to determine the polarity of these things, and I have found that there is a standard, but it isn't exactly adhered to, and I'll show you what that is. Let me get the one that adheres to the standard. As far as I could tell, the ones from Super Bright LEDs adhere to the standard, which is when you get an LED, there'll be 2 leads on it. One will be slightly longer than the other one. And the one that is slightly longer is the positive end, right? So that one, even this one is bent a little bit, but it's not a big difference. The one that's slightly longer there, it's the positive one. Now, you can also kind of tell that the positive end is the small bit inside. If you look inside the LED, there's a big part on this side, and then there's a small part on the other side. And the small part is going to be the positive side. And the big part is going to be the negative side. Now, I wire my resistors to the negative side. Alright, there's a few different ways to wire up LEDs, and I just wanted to show the basic circuit designs. This is the basic design. For a single LED, you have, positive battery and negative battery, and so you've got the LED out like that, and then you've got the resistor on the negative side. Okay, and I've marked these VF for forward voltage and R1 for resistor 1. Okay, now when this is the circuit that we use to calculate our resistor and everything, but it's not very common that we actually just wire up one LED to the battery like this. What we usually do is something more like this. Now this is how that I have the lights on my slow stick wired up, and that is the battery, and then out on the LED we just have the LED and the resistor right next to each other and wired in parallel to the source voltage. Okay, and you can do as many LEDs as you want this way, and all you have to do is figure out this basic calculation for each LED, wire up your LEDs, hook them all to the source voltage, and it's fine. Now, in a quadcopter or in an airplane, we don't do it this way exactly. What we do really is more of a star formation. Okay, and that is, okay, you've got the positive and negative terminal of the battery. We basically have a wire that just goes out to the LED. And then we have the LED sitting out there on the wire with its resistor on the other side, and the wire going back to the negative terminal again. So we can wire up as many LEDs as we want to this way, right? Around, and then another one around this way. So we can. That's how I did my Blade MQX. Was I did 5 circuits like this back to the battery. And I just calculate the resistor for each one separately. Now that works pretty good. Because I used 3.3 volt LEDs and my source voltage was 4.2 volts at the max, I could only put one LED out on each thing. But if you're using a higher voltage, you can put multiple LEDs out here with only a single resistor, and that is additional efficiency that you can get. So keep that in mind. If your LEDs, are the correct voltage, you can put multiple LEDs out, and that is the way that the light strips work. There's 3 LEDs in series with one resistor, then back to the source voltage again. So that can be done if you have the proper amount of LEDs, proper voltage. You can figure that out. Now, the way that we figure out what resistor to use on each LED is very simple. We just start with Ohm's law. Okay, voltage equals current times resistance. That's the normal expression of Ohm's law. If we do a little bit of algebra, we can turn this into a resistance finder, right? We know our voltage and we know what our current is that we want to be. We're just trying to find the resistance. So we do a little algebra and we end up with this. Voltage divided by current equals resistance, right? So we turn that around to make it easier to work with, and we get this. Resistance equals voltage divided by current. Now, if we know the voltage and we know the current, which we do, right? Our current that we want is that 20 milliamps or whatever the LED said that it was. And our voltage that's the tricky thing, is the voltage of a circuit with an LED in it requires a little bit more math. Now, that math is this. Okay? Now, if we have a voltage source, which is our battery, and a forward voltage for our LED, what we simply do is subtract the forward voltage from the voltage source. The LED acts like a voltage eater in the circuit. basically subtracts voltage off of what we have. So again, we use Ohm's law and we take our current and we figure that out. If we run that calculation for the LED that I have, one of the green ones, we have 4.2 source voltage, okay, and we have a 3.5 forward voltage LED, and we want to put 20 milliamps through it. So what we have is divide that by 0.020. Now that's 20, right? 1,000ths milliamps. Okay. I always write out the third zero, right? This is tenths, hundredths, thousandths. So we got 20 thousandths. If you screw that up, you could really have a problem. So make sure you understand, milliamps or amps or whatever you're working in. So then when we multiply that out, we've got 0.7 divided by 0.02, and that gives us a 35 ohm resistor. So just as an example, for 20 milliamps on a 1S LiPo battery, I need a 35 ohm resistor. Now here is that green LED that I ran the calculation for before, and here is the 33 ohm resistor that I'm going to use on it, and I'll just show you how I wire that up. Now remember, I'm going to wire the resistor to the negative side. I try to do this pretty close to the edge, and basically what I just did was wrap the resistor wire around, and then I angled the LED lead off to the side. And the reason is because I basically want a straight shot down this way with my resistor, and I don't want to have like a big blob of stuff here. So the next thing to do is to cut off the leads as close as you can get them. As close as you can get, cut off the leads, right like that, and use your pliers to get it down. Now that one is not very good. It should be tighter than that. But once you have that, put it in your helping hands there. Okay. Solder it as quickly as possible. Okay, that's all you need. Do the same thing with your magnet wire. Get it up there as close as you can. And on magnet wire, I just let the enamel melt with the solder. Try not to get too much though. And that will be fine, just like that. So that's how everything looks there. That side is not so good. This side is okay. So then just solder the wire on the other end of the resistor the same way, just like that. And now, before you put your heat shrink on, there's one thing that you're going to want to do, and that is mark the wire that you think is the positive side. Now, I soldered my resistor on the negative side, so this one is the positive wire. And what I do is I go out to the end of that wire, and I fold it up, put some folds in it, so that you know that that one is the positive end. Make your piece of shrink tube just long enough to go over the resistor and over the last solder joint at the end. Okay, it needs to go all the way down that far. So put that on and shrink it up and run the other wire right next to it. Okay, and check and make sure nothing from here is going to poke through the other side. Then get a piece of heat shrink that fits over both wires. And some people do like to put the end of the heat shrink over the LED just a little bit. One thing I did do is I made it slightly shorter than what's needed. And I'll show you why. Now, if you do it that way, you can see, which one you wired your resistor to. So that might be helpful. It's perfectly insulated. The magnet wire's fine right here anyway, so you don't really need to make this super long. And that can help reduce the weight a little bit. But there you have a nice LED. It's wired up, and you can bend this around a little bit, but you want to be careful bending this part. Now, I wanted to just show one last thing here, which is pretty simple to do, and that is how to make an RC dimmer switch. If you want your lights to be able to go on and off and controlled by the radio, then you need an extra channel. You need to be able to send signals down that channel, and you need a brushed motor ESC. Now this right here is an 8 amp brushed motor ESC, and it is designed for LiPo power and stuff. And what I did was I just put a JST plug on the power end. I plugged it into my receiver the normal way. Now I plugged it into the throttle channel for demonstration, but you probably want to use some other channel. You could use your gear channel or whatever. Now if you're not going to use the BEC, remember to disable the red wire and stuff. But basically what I can do is then for the demonstration, I just hooked my LED directly to the other end of the motor. So this would be where your motor wires, this is the motor wires for the ESC. And since it's a brushed motor ESC, all it does is regulate the voltage up and down to the end of these wires. So I can use it as a dimmer switch, and I'll just show you that real quick here. Let me plug it in. Now, to be honest, I'm kind of surprised that the receiver is actually running on this 1-cell battery, because I'm just using a 1-cell battery. But you can see the ESC, when it activates, it actually has some arming pulses that come out, and you can see that it's waiting for me. And if there was a motor hooked up, you would hear that. So let's see, what's it doing? It's waiting because I have the throttle down. So if I put the throttle all the way up, there you can see it's going to arm, I think. So I put it down. Okay. So now I can use the throttle stick as a dimmer switch. It's doing something funny. You have to make sure you arm your ESC correctly, but so you can see you can use it as a dimmer switch. I probably have some low voltage cutoff happening here or something like that, but so there you go. Very simple dimmer switch.